The noise emanating from the 34.5 kV switchgear could stem from several potential issues. Firstly, consider corona discharge. This phenomenon occurs when the voltage stress surpasses the insulation strength of the air, leading to ionization and producing a hissing or crackling sound. Vacuum circuit breakers are designed to minimize this, but it can still manifest under certain conditions. Secondly, mechanical movement might be the cause. Some circuit breakers generate audible noises during operation because of moving mechanical components. The nature of these noises can differ based on the circuit breaker's design and its age. Thirdly, electrical arcing is a possibility. If the noise is accompanied by a burning smell or visible light, it might indicate electrical arcing. Arcing can harm the circuit breaker and present a safety hazard. Fourthly, examine loose or damaged connections. Loose connections can vibrate under load, resulting in a buzzing or crackling sound. Furthermore, damaged connections can also trigger arcing or heating. To address this issue, remember safety first. Ensure that you are adequately qualified and equipped to carry out the following steps safely. Begin with a visual inspection. Open the circuit breaker compartment and meticulously inspect for any visible signs of arcing, damage, or loose connections. Next, employ thermal imaging. Use a thermal imaging camera to identify any hot spots that might point to electrical arcing or compromised connections. Then move to electrical testing. Conduct insulation resistance tests to assess the integrity of the electrical insulation. And contact the manufacturer, which in this case is Siemens. Report your findings to them and ask for their assistance. They might offer technical guidance or dispatch a technician for a more thorough inspection. Also, keep in mind some additional considerations. Even though Siemens stated there was no need for concern, it's essential to take any unusual noises seriously. Medium voltage circuit breakers are vital components of power systems, and any potential problems should be addressed promptly. It's advisable to consult with an experienced electrical engineer or a qualified technician to comprehensively evaluate the situation and determine the proper course of action. When performing a visual inspection, look for discoloration on insulators. This discoloration can indicate surface cracking, which is a precursor to flashover. Also, check for any signs of rodent activity, such as droppings or nests. Rodents can chew on insulation and wiring, creating a path for arcing. Ensure all bolted connections are tight and free of corrosion. Use a calibrated torque wrench to tighten connections to the manufacturer's specifications. Inspect all grounding connections to ensure they are intact and providing a low resistance path to ground. When using thermal imaging, scan all connections, bus bars, and components for temperature anomalies. Compare readings to similar components to identify potential problems. Document all findings with photographs and detailed notes. For electrical testing, perform insulation resistance tests on all phases to ground and phase to phase. Use a megometer with an appropriate voltage rating for the equipment. Compare readings to manufacturer's specifications and historical data. Conduct contact resistance tests in the circuit breaker contacts to ensure they are within acceptable limits. Perform timing tests on the circuit breaker to verify that it is operating within the manufacturer's specified parameters. If any discrepancies are found during testing, consult with the manufacturer for further guidance. Consider the environment the switchgear is located in. High humidity, temperature fluctuations, and corrosive atmospheres can accelerate the degradation of insulation and connections. Implement a preventative maintenance program that includes regular cleaning, inspection, and testing. Keep accurate records of all maintenance activities, including dates, findings, and corrective actions. Train personnel on proper operating procedures and safety precautions. Ensure they are aware of the potential hazards associated with medium voltage equipment. Review the circuit breaker's maintenance history to identify any recurring problems. Check for any outstanding recalls or service bulletins issued by the manufacturer. If the circuit breaker is nearing the end of its service life, consider replacing it with a newer model. Ensure the replacement circuit breaker is compatible with the existing switchgear and meets all applicable standards. Before working on any electrical equipment, de-energize the circuit and verify the absence of voltage using a properly rated voltage tester. Use appropriate personal protective equipment, including gloves, eye protection, and arc flash protection. Follow all applicable safety regulations and procedures. When contacting the manufacturer, provide them with as much information as possible, including the circuit breaker's model number, serial number, and operating history. Describe the noise in detail and provide any relevant test data or observations. Ask them if they have encountered similar issues with this type of circuit breaker. Inquire about any recommended maintenance procedures or modifications that may help resolve the problem. If the manufacturer is unable to provide a solution, consider consulting with an independent electrical testing company. These companies have specialized equipment and expertise to diagnose and repair complex electrical problems. Remember that working on medium voltage equipment can be dangerous. If you are not qualified to perform the necessary tests and inspections, it is best to call a professional. Ensure the professional has the relevant experience to address this particular type of equipment. When assessing the risk of arc flash, consider the available fault current and the clearing time of the overcurrent protection devices. Perform an arc flash hazard analysis to determine the appropriate level of personal protective equipment. Install arc flash mitigation devices, such as current limiting fuses or arc flash relays, to reduce the risk of injury in the event of an arc flash. Regularly review and update the arc flash hazard analysis as changes are made to the electrical system. Educate personnel on the dangers of arc flash and the importance of wearing appropriate personal protective equipment. Implement a lockout-tagout program to prevent accidental energization of equipment during maintenance. Use insulated tools when working on or near energized electrical equipment. Maintain a safe working distance from energized equipment. Avoid wearing metallic jewelry or clothing when working on electrical equipment. Do not work alone on electrical equipment. Have a qualified person present to provide assistance in case of an emergency. Keep the work area clean and free of obstructions. Use proper lifting techniques when handling heavy equipment. Ensure that all equipment is properly grounded. Inspect all equipment before use to ensure it is in good working condition. Report any damaged or malfunctioning equipment immediately. Follow all applicable safety regulations and procedures. In addition to audible noises, also be aware of other potential warning signs, such as unusual smells, smoke, or discoloration. Investigate any unusual conditions immediately. Do not attempt to troubleshoot or repair electrical equipment unless you are properly trained and authorized. Always err on the side of caution when working with electricity. Consider the age of the equipment. Older circuit breakers may be more prone to problems due to wear and tear. Check the manufacturer's recommended maintenance schedule and perform all required maintenance on time. If the circuit breaker is past its expected service life, consider replacing it with a newer model. Newer circuit breakers may have improved features and reliability. Also consider the loading on the circuit breaker. Overloading the circuit breaker can cause it to overheat and fail. Ensure that the circuit breaker is properly sized for the load it is serving. Check the load periodically to ensure it is not exceeding the circuit breaker's rating. Also verify the proper coordination of protective devices. Miscoordinated protective devices can cause nuisance tripping or prevent the circuit breaker from clearing a fault in a timely manner. Perform a coordination study to ensure that all protective devices are properly coordinated. Regularly test the protective devices to ensure they are operating correctly. Consider the impact of harmonics on the circuit breaker. Harmonics can cause the circuit breaker to overheat and fail. Use harmonic filters to reduce the level of harmonics in the electrical system. Regularly monitor the harmonic content of the electrical system. Consider the use of surge protection devices. Surge protection devices can protect the circuit breaker from damage caused by voltage surges. Install surge protection devices at the service entrance and at critical equipment. Regularly inspect the surge protection devices to ensure they are functioning correctly. Also, be aware of the potential for lightning strikes. Lightning strikes can damage electrical equipment, including circuit breakers. Install lightning protection systems to protect the equipment from lightning strikes. Regularly inspect the lightning protection systems to ensure they are functioning correctly. Proper documentation is also key. Maintain accurate records of all inspections, tests, and maintenance activities. Keep copies of all manufacturers' manuals and drawings. Store all documentation in a safe and accessible location. Review the documentation regularly to identify any potential problems. Training is paramount. Provide regular training to personnel on the proper operation and maintenance of electrical equipment. Ensure that personnel are aware of the potential hazards associated with electrical equipment. Keep training records up to date. Communication is also essential. Encourage personnel to report any unusual conditions or concerns immediately. Establish a clear communication channel for reporting electrical problems. Respond to reports promptly and effectively. Finally, always prioritize safety. Make safety the top priority in all electrical work. Follow all applicable safety regulations and procedures. Use appropriate personal protective equipment. Do not take shortcuts or compromise on safety. Safety is everyone's responsibility. When assessing the noise, try to determine if it is constant or intermittent. Constant noise may indicate a continuous problem, such as corona discharge. Intermittent noise may indicate a problem that only occurs under certain conditions, such as when the circuit breaker is loaded. Try to pinpoint the source of the noise. Use a stethoscope or other listening device to help isolate the noise. Be careful not to touch any energized parts while using a listening device. Record the noise using a microphone or other recording device. This may help you to analyze the noise and identify its source. Compare the noise to recordings of known electrical problems such as arcing or corona discharge. If possible, take pictures or videos of the equipment while the noise is occurring. This may help you to document the problem and show it to others. Consult with experienced electricians or engineers to get their opinion on the noise. They may have encountered similar problems in the past and be able to offer valuable insights. Don't ignore the noise. Even if it doesn't seem to be causing any immediate problems, it could be a sign of a more serious underlying issue. Address the noise promptly to prevent it from escalating into a major problem. Remember, a proactive approach is always the best approach when it comes to electrical safety. Regular inspections, testing, and maintenance can help to prevent electrical problems before they occur. By following these steps, you can effectively troubleshoot and resolve the unusual noise emanating from the medium voltage breaker. And you can maintain a safe and reliable electrical system. Another thing to consider is the type of vacuum interrupter used in the circuit breaker. Different types of vacuum interrupters have different operating characteristics and may produce different noises. Consult the manufacturer's documentation to determine the type of vacuum interrupter used in your circuit breaker. Check the vacuum interrupter for signs of damage, such as cracks or discoloration. Damaged vacuum interrupters may produce unusual noises. If you suspect that the vacuum interrupter is damaged, contact the manufacturer for replacement. When performing insulation resistance tests, pay close attention to the polarization index. The polarization index is the ratio of the insulation resistance after 10 minutes to the insulation resistance after 1 minute. A low polarization index may indicate that the insulation is contaminated or degraded. When performing contact resistance tests, use a full wire measurement technique to minimize the effects of lead resistance. Compare the contact resistance measurements to the manufacturer's specifications. High contact resistance can cause overheating and failure of the circuit breaker. When performing timing tests, measure the opening time, closing time, and rebound time of the circuit breaker. Compare the timing measurements to the manufacturer's specifications. Incorrect timing can cause the circuit breaker to operate improperly and damage the equipment it is protecting. If you find any problems with the circuit breaker, do not attempt to repair it yourself. Contact a qualified electrician or engineer to perform the repairs. Ensure the electrician or engineer has the proper training and experience to work on medium voltage equipment. Use only genuine replacement parts from the manufacturer. Do not use generic or aftermarket parts. Generic or aftermarket parts may not meet the manufacturer's specifications and could damage the circuit breaker. After performing any repairs, thoroughly test the circuit breaker to ensure it is operating correctly. Document all repairs and testing results. Keep accurate records of all maintenance activities. Regular maintenance is essential for ensuring the safe and reliable operation of medium voltage circuit breakers. A well-maintained circuit breaker will provide years of trouble-free service. A poorly maintained circuit breaker can be a safety hazard and can lead to costly downtime. Develop a comprehensive maintenance plan for your medium voltage circuit breakers. Follow the manufacturer's recommended maintenance schedule. Perform regular inspections and testing. Address any problems promptly. Keep accurate records of all maintenance activities. By following these steps, you can ensure the safe and reliable operation of your medium voltage circuit breakers. Always remember that electrical safety is paramount and any unusual noise or condition should be investigated by qualified personnel.